Alrighty, today we are going to discuss section 9.6, identify symmetry. So our goal is to identify line and rotation symmetry of a figure. So our first term is line symmetry. Line of symmetry, it is a line of reflection within an object. Basically, if you can take an image and fold it in half and have both halves identical, then you have what's called line symmetry. So for each of these figures, we are asked to find how many lines of symmetry does each figure have. So we have a regular hexagon, a horizontally stretched hexagon, and whatever this shape is here. For the regular hexagon, we can go through the midpoint of opposite sides and have 3 lines of symmetry there. We can also go through the opposite vertices and have 3 more for a total of 6. When we have the horizontally stretched, we can go vertically. We can't go diagonally here because the sides won't fold together. The only other way we can go is through the middle horizontally for a total of 2. And over here, this figure has none. There's nowhere I can fold it and get 2 identical images. Some real life examples of where you see symmetry. How many lines of symmetry do you see in each of these? So with the flower, it's a little tricky, but you can go right down the middle, vertically and horizontally, as well as diagonally between petals as well, for a total of 4. With the starfish, you can go right down each spine for a total of 5. And lastly, with the goat, we have 1 right down the middle. And that's line symmetry, just looking for where you can fold it. The other type of symmetry is rotational symmetry. Rotational symmetry, when you can rotate an image 180 degrees or less to get the image itself. And then the caveat to this is all the multiples up to 360. Why 360? 360 is a full rotation. Everything has 360-degree rotational symmetry because you get back to where you started. So we look at this fan, for example. We started here. We've marked this line for reference. If you rotate it 45 degrees, these 2 images are not equal. They're not the same. So there's no rotational symmetry. But if I look from the 0 to the 90, those images look the same. So we say that yes, there is 90-degree rotational symmetry and all the multiples of it. So that would be 90, 180 degrees, and 270. And as you can see here, 180 is shown. Identify if the figure has rotational symmetry. So we have here this original rectangle, and I will trace it. So if we rotate it 90 degrees, still not the same. But if I rotate it all the way over to 180, we see that it's the same. So that is rotational symmetry. Here with the regular hexagon, there are 6 sides. One thing you can do, an easy way to do this, is to take 360 and divide it by the number of sides to see what your rotational symmetry will be. 60 degrees. So if I rotate a regular hexagon 60 degrees, it should be the same. And again, this is contingent on it being regular. And since it's 60, it'll be all multiples of 360 as well. Here with the arrow. The only time this arrow is going to be pointing up is if I go right back to start. So this one has 0 rotational symmetry. Now, if it had the arrow on the other side, something like that, where it was equal on both sides, you could have 180 rotational symmetry, but this one doesn't, so it doesn't have the rotational symmetry. Lastly, what I would like you to do is identify all symmetries. When they say all, they are looking for line and rotation. As we see, there are 4 lines. You can go through the midpoints of opposite sides, as well as through the diagonals. So that creates 4 lines of symmetry. Also, you have rotational symmetry. It's a regular figure. 360 divided by 4 would be 90. So 90, 180, and 270.